Today we're working on a graphic organizer. So we're starting with the idea that we have two parallel lines, lines M and N, that are going to be cut by this transversal. And I know that they're parallel because of these little marks right here. So they're telling me, these little triangles tell me these two are parallel, and this is our transversal. So I'm going to remind you of that. I'm going to write that in here. Transversal. All right. And then line M is parallel to line N. Now, we have a lot of angle relationships to talk about, so let's get started. Corresponding angles, they correspond. They are in the same position. So corresponding angles, first of all, are congruent. So you can write out the word congruent, or you can put the congruent symbol. So corresponding angles are always congruent. Corresponding are in the same position. So what am I talking about? Same position. If it's in the top right-hand corner, it's in the top right-hand corner. So take a minute and look at your picture here. If we take these four angles and we take our line and we slide it down, angle 1 is sort of the top right of the transversal, and so is angle 5. So angle 1 is congruent to angle 5. That's the rule there. Another corresponding angle would be 2 and 6, bottom right, bottom right. So again, if we took this and we just slid it down, angle 2 would line right up and be in the same position as angle 6. So angle 2 is congruent to angle 6. We also have angle 3 congruent to angle 7, bottom left. Again, these are corresponding angles. And angle 4 is corresponding with 8, which makes them congruent. Now, this is only true for parallel lines. They're corresponding angles, but they're only congruent for parallel lines. Okay, next, we've got this alternate exterior and alternate interior. So we can go ahead and slide this up. In your alternate exterior and alternate interior, when we say alternate, they alternate the transversal. So I'm going to put a little arrow there. They alternate the transversal. Interior are the inside angles. Okay, so 2, 3, 5, and 8. Where exterior, if we cover this up, are the 1, 4, 6, and 7. All right, so alternate interior angles. So 2 is interior and it alternates with 8. So angle 2 is congruent to angle 8, and I should put that down. That is the relationship. Alternate interior angles are congruent. What's the other set of alternate interior angles? Angle 3 and angle 5. So they alternate this transversal and they're inside the parallel lines. Angle 3 is congruent to angle 5. All right, now let's look at alternate exterior. Again, they're the ones on the outside. So 1 is exterior and so is 7, and look, they alternate. Angle 1 is congruent to angle 7. The other set of alternate exterior are 4 and 6. Angle 4 is congruent to angle 6. Alternate exterior angles are also congruent. And I guess, let's just slide up here real quick. Let's go ahead and make sure we remember this. So this symbol stands for congruent. That's what that means. And we are going to be using our angle symbol in a minute. So that is your angle symbol. Okay? So just in case, congruent symbol, angle symbol. All right, so we've got our corresponding, the ones in the same positions. We've got alternate interior, alternate exterior. So there's 4 of these and only 2 sets of these. And then we're going to change it up a little bit. We have these same side interior, or the other term is consecutive interior. So either term can be used, but same side interior and consecutive interior, they are not congruent. They are supplementary. Do you guys remember what supplementary meant? Supplementary are 2 angles that add up to 180 degrees. So I'm going to write that down here. 2 angles. So the definition is supplementary. 2 angles that add to 180 degrees. All right, so supplementary are 2 angles that add up to 180 degrees. So now we need to find the same side interior. Notice we also have same side exterior. So supplementary, two angles that add up to 180 degrees. Do you guys remember what it was when they add up to 90 degrees? We talked about it Friday. Those were the complementary angles, two angles that add up to 90. Okay, so if you look at this, we just talked about alternate interior, where they alternate in their inside and alternate in inside. So now we're talking about same side interior, same side of transversal. That's what we're talking about. Same side of transversal. So if you look for the same side interior, that'd be angles 3 and 8. Okay, so they're not congruent though. This was the one that's different. It's the measure of angle 3 plus the measure of angle 8 is 180 degrees. These two angles are going to add up to 180. So the other day we had proven this. This is a linear pair on a line. We're going to talk about that. These add up to 180. And if angle 2 is the same as angle 8, then 3 and 8 must also add up to 180. So again, anything forms a line, 2 and 3 add up to 180, and so 2 is the same as 8 because of alternate interior, so 3 and 8 must add up to 180. So these are your same side interior. There's another set of same side interior, and it's 2 and 5. So it's not that they're congruent. The measure of angle 2 plus the measure of angle 5 is 180 degrees. Now I have a habit of making that a cursive M, but it's really just an M standing for the measure. Here we're talking about objects, and angle is congruent to angle. Objects are congruent, but angle measures are what we have to use to add up. Okay, with the same idea, we have the same side exterior. They have the same rule. They are also supplementary. Okay, these angles are also supplementary. So if they're same side exterior, or the other term is consecutive, consecutive meaning in a row. So same side exterior, we're looking at 1 and 6. They're on the same side of the transversal, but they're exterior. Okay, so that's a little bit different because this is easy to see, same side, they're right beside each other. Same side of the transversal, but on the outside. So the measure of angle 1 plus the measure of angle 6 is 180 degrees. The measure of angle 4 and angle 7 is also 180 degrees. All right, so these are the ones that I think people forget about, and we use them a lot. So same side, they add up to 180. Now we have two more, and it's going to be hard because we're going to have to go back and forth on this, but we have these things called vertical pairs. So I'm going to tell you which ones are vertical pairs here. Vertical pairs are like that X, okay? So if you come back up here, there's a lot of vertical pairs. 1 and 3, so the top and the bottom of the X, or 4 and 2. Those are vertical angles, and they're always congruent. So vertical angles are always congruent. I'll write it out because I have a little more room there. Vertical angles are always congruent. And then look back up your picture. 1 and 3 are vertical angles. So angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. So here again, 1 and 3, 2 and 4. All right, take a minute and determine what your vertical angles are here. What would 5 go with? Will be the opposite or vertical of angle 5. Angle 7. All right, so angle 5 is congruent to angle 7. And there was one more, angle 6 and 8. Okay, so you have 4 sets of vertical pairs. So I'm also going to put the term here that you might see opposite angles. So vertical pair or opposite angles. All right, last one we talked about, what we didn't officially write down, are called linear pairs. Linear pairs are two angles that form a line. So linear pair of angles are also supplementary. So that's what's hard, is most of these are congruent, and then we get some that add up to 180 degrees. A linear pair are two angles that form a line. Two angles that form a line. Now, that's a big difference. Supplementary are any two angles that add up to 180 degrees. They don't have to buddy up. So, linear pair, two angles that form a line. A linear pair is always supplementary. So what's different about a linear pair and supplementary? Here's the idea. Angle 2 and angle 5 are supplementary because they add up to 180 degrees at same side. However, 2 and 5 aren't a linear pair, but 5 and 6 are. See that line that's broken up with that ray? 5 and 6 are a linear pair, but so are 6 and 7. So are 8 and 7. So are 5 and 8. We have like 8 linear pairs. Any two angles side by side that form a line are a linear pair. Do you see how I can go around? 2 and 3 are a linear pair, and 4 and 3 are linear pairs, and 1 and 4 are linear pairs. So we're not going to write them all, but any linear pair make a line, and that means they have to add to 180. So that's what's special about them. They're not just 180 degree sum, but they form a line. So I'm going to go down here and just do angles 1 and 2, angles 2 and 3. So the measure of angle 1 plus the measure of angle 2 is 180 degrees. And you can see we have a whole lot of examples. Okay, I want to do one more thing. So I want to flip our paper over and sketch parallel lines cut by transversal and just give you an example. That way we can fill this in again. Okay, so you know what? Let's do this extension. That's what I forgot. So you have your paper flipped over? No, just draw these on your paper. You don't have anywhere else for it. So I want you to see how quick and easy this can be. I drew lines here. We'll do this on the back of your paper to do some examples. I have parallel lines here cut by a transversal. And guys, what I have inside here are these alternate interior angles. So what do we know about alternate interior angles? They're congruent, aren't they? See how they alternate the interior of the transversal? So what's the measure of angle x? X is 130 degrees. So get your parallel line, sketch that. You have this angle in here. This angle is congruent to this angle. That's all I needed to know. Now, label that 130. That's all we had to do. We're done. But take a minute and think about this. If this is 130 degrees, what's this angle? Well, it's on a line, isn't it? So you have 180 degrees on your line. If that's 130, what's this have to be? Doesn't it have to be 50 degrees? And if I know that's 50, this would also be 50 because of linear pair or alternate interior. Now tell me about a vertical angle. This angle up here, 130, isn't that vertical with this angle here? This is an alternate exterior. So there's 130, or vertical angle. See how all these things are true? Vertical angles, 50 degrees, or a linear pair. Vertical angles, 50 degrees, linear pair, corresponding. So all rules we can use. So do you see if you know one angle, you can find all of the other ones? Okay? All right, look down at this next one. Go ahead and give a quick sketch here. Parallel lines cut by transversal. And I'm going to tell you right now, these are the alternate exterior angles, aren't they? Alternate exterior. And alternate exterior angles are equal. So that means that if this is 40, this angle has to be 40. So if I need to find x, wouldn't I know that 2x plus 10 must equal 40? So I'm going to solve that. Remember, cancel it by subtracting it. 2x equals 30. And then it's 2 times x, so I divide both sides by 2. And I get x equals 15. Now, I'm running out of time here. I think I'm done. All right.